In this next video we're going to look at developing our knowledge of multiplying fractions and practicing cross-cancelling. Our method, which in the previous video allowed us to tackle very difficult multiplying fractions and get very simple answers in few steps. So, here's how we did our cross-cancelling. We wrote the sum as 1 multiply, and then we looked for any common factors on the numerator or the denominator. Can you see any? Hopefully you've spotted this pair, which I'll do first. They're both in the 5 times tables, so I'm going to divide them both by 5. Look at the other pair that's left. Do they cancel? Good spot if you have seen it. They are both in the 12 times tables. That is half of that. This leaves me with 1 times 3 and 5 times 2, which is 3/10. You don't need to write this step. In fact, you can do your cross-cancelling up here at the start, if you wish. I'll continue as I am, and then I'll show you how to reduce the setup. If you watch the way I write my fractions, you might even see a pattern to how I come up with the numbers. Divide them both by 7. So let's let it out. Divide by 7. Divide by 7. Aha, these are both in the 2 times tables. So that's 9 and that's 6. Now, if you're watching carefully, you'll look at 6 and 9 and you'll spot something. That's right, they're both in the 3 times tables. So I can simplify that to 3 and that to 2, which makes my answer 2 over 15. 1 times 2 and 3 times 5. Now with this topic, the key thing is spot the cancelling, take care cancelling. If you need to do workings out on the side of your page, do those. And then of course you multiply what is left. Now, I think at this stage you probably would normally practice some of these. Let's try a couple more just to see if there's anything else we haven't covered yet. Okay, so here we've got 3 fractions multiplied. So how does it work? Well, we know that our rule will multiply the first two and then the second one, because if you had 2 times 3 times 5, you would do that, then times it by that. So we're going to multiply them all together. Now it's time to look for some cancelling. Hopefully you've spotted those wonderful 5s, and you're going to go 5 and 3. There's a clever cancelling here that I'm going to show you. Three times 7. That's 21. That's 21. So they cancel to 1, because 21 over 21 is 1. Some of you will have seen 3 and 3 and wanted to cancel those. That's okay as well. You'll get to the same answer. But I'm now left with 1 times 5 times 1 and 8 times 1 times 3. So that's 5 on the numerator and 24 on the denominator. So far, so good. So if it's 3 fractions, it's the same. If it's 2 fractions, it's the same. What about this situation? This is a very common one that throws people off all the time. If you think back to just a couple of videos ago, we were tackling this problem, and we tackled it rather well. But we wouldn't have seen it written in this format. We'd have seen it written like this. Where of was there instead of multiply, and we know those two are equivalent. And we'd have seen these two the other way around. So is that an issue? Well, first off, what about switching them round? Does that change the sum? Have a look at those two. Multiplication does not change if the order changes. So that's great news. And we know that of and times are equivalent. So if you're given this sum, you can just work out this sum. Or 60 times 2/3 can be done as a multiplying fraction. And some of you will prefer this way. My question for you is, what's the denominator of this fraction? 60 whole ones times 2/3. If they're whole ones, how many of them does it take to make a whole one? That might sound like a strange question. How many of these does it take to make a whole one? It takes 1. So your denominator is actually 1. Well, now we can multiply our fractions like before. Find the pair where the cancelling occurs, divide them both by 3, and then get our answer. You'll notice I didn't put divided by 1, because there's no need. If we had done it the original way, you'd have found 1/3 of 60 by dividing it by 3, which would give you 20. Then 2/3 of 60, you'd have multiplied by 2 to get 40. So both methods are equivalent. You're nearly there with multiplying fractions. There's one major hurdle to overcome, which I'll show you in the next video.